Hello, YouTube. This is Mr. Bakari, and today we are going to evaluate trig functions, that is, find ratios from given angles. Okay, so we're going to do this using the unit circle and special right triangles. So we're finding exact values, exact trigonometric values from special right triangles. Now, first, let's look at a trig function and understand something. The angle, theta, is the independent variable or input, and the trig ratio, y over r with sine, is the dependent variable or the output. So I have another video where we find theta. This time we're doing the opposite. We're given an angle, and at that angle, we're asked to find a trig ratio. Okay, so that's what we're doing here. So let's look at some examples. All right. First, we've got what is secant at negative 7 pi over 6. So first and foremost, you need to know your trig ratios. So secant is r over x. R over x. Write that right there. No. Okay. So negative 7 pi over 6. All right, let's look at negative 7 pi over 6. So we are going to go to our initial position here on the positive side of the x-axis, and negative angles are measured in a clockwise rotation. So negative 7 pi over 6 is just past pi, which is right here. Pi over 6 past that, which is right about here. So I'm going to draw a special right triangle right there. Now, the denominator of the angle in terms of pi indicates the reference angle that corresponds to one of the special right triangles. So if we look here that this is a sixth, that tells me that my reference angle is going to be 30 degrees. All sixes, okay? So now I got to recall my special right triangle across from 30, 1, across from 60, negative square root of 3 because I went left on the x-axis, and the radius is 2. Okay? So now to evaluate this at negative 7 pi over 6, secant, I just take r over x. So r over x is 2 over negative square root of 3. Okay, but I can't leave my answer like that. I need to rationalize the denominator. So my answer is negative 2 square root of 3 over 3. Okay? And that is secant at negative 7 pi over 6. All right, let's go to the next one. Sine at negative pi over 2. So again, we are going in a negative direction, measuring in a negative direction, and pi over 2 is straight down here. So this is what we call a quadrantal angle, falls on the y-axis. And that coordinate right there, since my radius is 1, is 0, negative 1. Okay? So 0, negative 1. Sine's ratio is y over r. So y over r here, y is negative 1, the radius is 1. Negative 1 over 1 is simply negative 1. Okay? So sine at negative pi over 2 is negative 1. All right, let's look at some more. What is cosecant at 3 pi over 4? This is a positive angle, so we're going to go in a positive direction, counterclockwise. And 3 pi over 4 falls right between pi over 2 and pi, right in the middle. So draw your triangle. And again, the denominator, when I'm given radians in terms of pi, the denominator tells me that my reference angle is 45 degrees. Okay, that's associated with the fourths. And then my special right triangle, 45, 45, 90. The legs are 1. That's a negative 1. And r is square root of 2. Okay? Cosecant is r over y. So what is cosecant at 3 pi over 4? R over y is simply square root of 2. Okay? What's really important here is that you're keeping your sign straight. Okay? X is negative over here in quadrant 2 and 3. Y is positive in quadrant 2. Okay? So R over Y is going to be positive. So keep that in mind. Watch your signs. Over here, cotangent at 5 pi over 6. Okay? So 5 pi over 6 is just shy of pi. So this is pi. This is 6 pi over 6. So 5 pi over 6 is about right there. Draw your triangle. And again, the 6 tells me my reference angle is 30 degrees. Across from 30 is 1. Across from 60 is negative square root of 3. And r is 2. Cotangent is x over y. X over y is negative square root of 3. Okay? All right, let's look at a few more. What is sine at pi? Well, we know where pi is. Pi is right here. Okay, so remember the coordinate at pi is negative 1, 0. So that's x, that's y. The radius is always 1 when we're looking at the unit circle. So sine is y over r, and y over r is 0. Okay? All right, cosine at 4 pi over 3. 4 pi over 3, positive angle, past pi, right? Because pi is 3 pi over 3. So a third past that brings us down here into the third quadrant. I'm going to draw my special right triangle. The thirds tell me my reference angle is 60. Okay? So the 3 corresponds to a reference angle of 60 degrees. Across from 60 is negative square root of 3. Across from 30 is negative 1. R is 2. R is always positive. It's a radius. Okay? Cosine is x over r, and x over r is negative 1 half. All right? Last two. Okay, if you want to try these on your own, go ahead and pause the video, give it a shot, come back, and we will go over them. All right, we're looking at cosine at negative pi over 2. Where's negative pi over 2? Okay, we're going to go in a clockwise rotation down here. Pi over 2 is right there. That is pi over 2. And the coordinate on the unit circle there is 0, negative 1. Okay, so x is 0, y is negative 1, our radius is 1, cosine is x over r. X over r is 0. All right. And the last example, secant at negative pi over 6. So negative pi over 6 is right there, approximately. Draw my triangle. The 6's all give me a reference angle of 30 degrees. Okay. Across from 30 is negative 1. Across from 60 is square root of 3. And r is 2. Okay. So secant is r over x, and r over x is 2 over square root of 3. Again, I can't leave a radical in the denominator. Go ahead and rationalize that, and you get 2 square root of 3 over 3. And that is it. That is evaluating trig functions on the unit circle. I hope you learned something there, and I will see you in the next video.